Welcome to this explainer. Today, we are diving into a really fascinating approach to science education. We're looking at a curriculum from the heroesmartacademy Godly Learners series. Now, what's so interesting here is how they take the absolute fundamental building blocks of the universe, the literal stuff that makes up everything around us, and they weave it together with moral and spiritual instruction. We're going to look closely at how they teach the highly structured design of the physical objects we interact with every single day, right down from the screens we're looking at to the very air we breathe.
But before we get into the microscopic details of atoms and chemical bonds, it's important to understand that this curriculum grounds its scientific exploration in a very specific worldview. They use John 1:3 to frame this up. The material presents the sheer complexity of matter not as some random accident, but as a deliberate, intentional design. So, for the students taking this course, learning about the different types of matter is framed directly as uncovering a divine blueprint.
So here is our roadmap for today. We'll start with the divine architecture, then move through elements, compounds, and mixtures. After that, we'll see how they go about testing your scientific knowledge, and we'll wrap up with education rooted in morality. Let's jump in.
Section 1. The Divine Architecture.
Right out of the gate, the curriculum establishes this golden rule. Absolutely every piece of physical material in the universe falls into one of three distinct categories. It's either an element, a compound, or a mixture. And understanding this classification is absolutely crucial. Whether you're an engineer designing aerospace materials, a chef trying to perfect a complex recipe, or just someone trying to purify drinking water, you have to know how these three categories behave. Because, as we'll see, they behave entirely differently, and the curriculum uses these distinctions to really shift how students view their everyday world.
Moving on to Section 2. Elements. The building blocks.
Elements are taught as the foundational building blocks. Think of them like the primary colors of the universe. They just cannot be broken down any further. An element is a pure substance made of only one kind of atom. This covers everything from solid, familiar metals we all know, like gold and iron, to the invisible gases, like the oxygen that literally keeps us alive. They are pure, unadulterated substances, no mix-ins allowed.
Help visualize this. The curriculum uses a great everyday example, a gold wedding ring. Imagine zooming in on that ring with a super-powered microscope. You know what you'd find? Nothing but identical gold atoms. It doesn't matter if you melt it down, cut it into tiny little pieces, or hit it with a hammer until it's completely flat. Its fundamental identity stays exactly the same. It is 100% gold. And that pure, unchanging consistency, that's the defining trait of an element.
All right, Section 3. Compounds chemically bonded together.
Now, unlike single elements, compounds lock multiple elements together, and there are two key phrases to really pay attention to here: chemically combined and fixed ratios. These elements aren't just casually sitting next to each other in a room, they actually bond together to form a completely new pure substance. The classic example? If you take exactly two hydrogen atoms and bond them to exactly one oxygen atom, you get water.
This is where it gets wild. Just look at the dramatic contrast here. On one side, we have sodium. This is a highly reactive metal that can literally explode if it touches water. And then we have chlorine, which is a toxic, poisonous gas. Encountering either of those elements on their own is a huge safety hazard. But when they chemically bond in a fixed ratio, they create table salt. I mean, think about that. A chemical bond completely transforms the hazardous properties of those original elements into a perfectly safe, edible crystal that we put on our French fries. It's like a magic trick, but it's science.
Which brings us to Section 4, Mixtures, a physical blend.
So mixtures happen when substances share the exact same space, but they absolutely refuse to chemically bond. Because they're only physically blended, and they lack those strong chemical bonds we just talked about, you can usually pull them apart using pretty simple physical steps. For instance, if you toss sand and salt together into a bucket, there's no chemical reaction. It's just a mix. And with a little water and a filter, you can easily separate that sand right back out.
A simple side salad is actually the perfect illustration of this physical blend. When you toss tomatoes, lettuce, and cucumbers together, you're definitely mixing them up, but they aren't chemically transforming into some weird, unrecognizable new substance. The tomato stays a tomato, the lettuce is still lettuce. Every single ingredient retains its original properties, which means if you're a picky eater, you can easily separate them back out using just a fork. No chemistry degree required.
This breakdown serves as a fantastic mental map of everything we've just covered. Elements are pure, single atoms, like that gold ring. Compounds are chemically bonded into entirely new substances, like table salt, and mixtures are physically blended but super easy to separate, just like a salad.
Keeping these three categories straight gives you a really solid framework for understanding all the physical matter around us.
Next up, Section 5, Testing Your Scientific Knowledge. To make sure these concepts are actually clicking, the curriculum throws in some great application-based questions. They ask things like, explain why water is a compound and not a mixture, or they challenge the students to devise a physical method to separate sand and salt. The goal here is to really lock in that practical, hard scientific knowledge before moving on to the broader philosophical lessons.
And finally, Section 6, Education Rooted in Morality.
Now this is where the HeroesMart Academy curriculum makes a really distinct pivot. They focus heavily on this core philosophy. Education without morality will hurt. The text argues that simply understanding the powerful properties of elements and compounds is actually dangerous if you don't have an ethical framework to go with it. They teach students that while science explains how matter works, morality dictates how we should use it. The ultimate goal is to use this knowledge to benefit the world and avoid causing harm.
They wrap up the lesson's arc by citing Romans 8:6-7, effectively intertwining all that academic knowledge with biblical morality. By framing the study of atoms, compounds, and mixtures through this spiritual lens, the curriculum aims to ensure that a student's scientific education is ultimately guided by a desire for wisdom, a drive to be helpful, and a pursuit of true peace of mind.
At the very end, the curriculum leaves its students with a practical challenge. Go identify the elements you use in your daily life today. But for us, stepping back and looking at this source material as a whole, it leaves us with a much larger question. We live in an age of incredibly rapid technological advancement. So how does explicitly blending foundational, hardcore science with moral instruction change the way the next generation will wield the building blocks of our universe? It's definitely something worth thinking about.